So today's presentation, today's class will be just going through understanding what programming languages are, okay, how we write them, how computer understand this programming languages, okay. So my first question to everyone, according to you, what do you think? What is a programming? What is a program? Before starting with programming languages, okay. So what is a program? So a program is nothing but a set of instructions, because machine, it cannot understand, right? It is not like human, it does not have human intelligence, right? So we have to pass all the instruction through a program, okay, and machine can only understand zeros and one, right? Because computer, what is computer? Computer is just an electronic device, and electronic devices only understand the binary code, right? That is zeros and ones. So I cannot write all my code into zeros and one, all my instructions into zeros and one, right? So you have this programming languages, okay? So your programming languages, what they do is, it is kind of language, okay? It's kind of an interface between your machine and you. So you pass your instruction to the computer through this programming languages. Now, whatever code you are going to write, it is considered as high level language. Okay. Whatever code we are going to write, it is considered as high level language. Now, this high level language needs to be converted into machine understandable form. What is machine understandable form? Your low level language. Okay. That is binary zeros and one. So I'm saying computer, it can only understand zeros and one, right? So whatever code you are going to write, it is kind of an interface that works as an interface between you, okay, between us and the machine. So machine, this only understands zeros, one. So we'll be writing our programs, we'll be writing our set of instruction through the programming languages. Now this programming language, what it will do is, whatever code, whatever command you have written, it will convert that in form of zeros and ones so that your machine can understand and it can perform its operation. Okay. So program is nothing but a set of instruction, right? So to machine, you have to pass all this instruction. Machine cannot do the task itself. For example, to add two numbers, you have to give the instruction. First, you have to say, read a value 10 and store that into A. Then you will say, read value B and store that into, read a value 20 and store that into B. After that, you can say your result or C equals to A plus B, right? A plus B. And then to see the output, what we do, we also pass an instruction to print the output. So print this C, print this output. So it is a set of instruction that we are passing. So your what it will do, it will convert this A first into binary. Then this B, it will read, this is your second instruction to read the second number and then convert that into binary. Then your C is nothing but the addition of A and B, right? So whatever binary equivalent you have of A, B, it will be added and stored in C. Then you are printing your C, but the output that you see is not in the form of binary. It is the way we have written it, right? So how it gets executed actually. So a programming language is a computer language that is used by programmers. For programmers, we are the programmers or developers, right? To communicate with the computers. It is a set of instruction written in any specific language, right? So it is nothing but it is just a set of instruction which is you can use different languages like C, C++, Java, Python, and there are tons of other languages as well to perform this kind of task. Right. So we have I mean, tons of programming languages: C, C++, Java, Python, C Sharp, .NET, and Go language. You have Scala, right? And there are a lot of them. And every day you'll see new programming language coming up, right? So these programming languages are nothing but they are just a way to communicate with your computer, right? Okay. Now, there are different types of programming languages. Okay, so we have low level languages. Okay, so low level language is machine dependent, and we have zeros and ones. Okay, so previously, before we had any kind of programming languages, the people used to write their codes in the forms of this low level language, which is zeros and ones. Okay, for example, if you have to do the addition of two numbers, what you will have to do is you'll have to, let's say 10 plus 20, you'll have to do this operation 10 plus 20. So if you see some programming languages like Fortran, and prior to that Fortran, it is called as low level programming languages. So people actually used to write this into low level codes. So what they will do is you'll have to remember the binary equivalent of 10. You will have to remember the binary equivalent of 20 as well, right? So what they used to do is you'll find the binary equivalent of 10 and find the binary equivalent of 20. Then based on your system, whether your system is of 32-bit, whether your system is of 16-bit, okay? So again, the machine, this low-level programming languages were machine dependent. So based on your system configuration, whether it is of 32-bit, whether it is of 16-bit, you used to do this binary conversion and store the values. And after that, you have to find out the binary equivalent of this plus as well. Okay. Even if you're writing some text also, let's say your name, okay, Aman, XYZ, anything, Aman. So not only with numbers, we have to work with text as well in program, right? So again, I will have to find out the binary equivalent of this A. I will have to find out the binary equivalent of this M, then A, N, right? So based on my system configuration, I will have 8 bytes to store the binary equivalent of A, right? So 1, 2, 3, 4, 5, 6, 7, and you have 8-bit, right? 1, 2, 3, 4, 5, 6, 7, 8. Let's say this is your 32-bit system. So you have 8-bit to store this A. You will have 8-bit, you require 8-bit to store this M. You will require 8-bit to store this A, and then this N. First of all, I will have to find out the ASCII value of A. Okay, what is the ASCII value of this capital A? So I'll have to find out the ASCII value first of all. Okay, after I have got this ASCII value, then I can convert that into the binary form and I can store it. So you see this conversions, you'll have to do a lot of tasks yourself. If it is a textual data, find the ASCII value. And once you have got the ASCII value, then convert that to binary. Once it is converted to binary, then you can store it and do this operation. So whatever symbols, whatever operation, plus, minus, okay, your multiplication, your division, all of this has some ASCII values. So you have to remember this ASCII values. So it will be some kind of number. ASCII value is nothing but some kind of number equivalent of the symbols or your characters as well. Now, once you get the numeric equivalent, you can easily convert that into a binary and then store it and then perform this. So this used to be in low-level programming languages, and it used to be machine dependent as well. For example, if you have written your code in 32-bit system, you cannot use that your code on 64-bit system, right? If you have written it in iOS, you cannot use it on Windows. So there was a lot of problem with this low-level programming languages. Okay. So the processor run low-level programs directly without the need of a compiler or interpreter. Now, if there was drawbacks, there was a positive as well. What was the positive? The positive was that the code that you used to write it used to take a lot of time, but once you have written it, the execution used to be really fast. Okay, the execution used to be really fast because you have already converted that into binary and stored it. So once it is stored, all you have to do is just use that particular application. Now we have this high level programming languages like C, C++, Java. These all are nothing but high level programming languages. Now, this high level programming languages, how they work. Okay, so I will just ask you a question. Let's say you have got a project in Japan. Okay, so you have got a project in Japan and you're working as a data scientist on their some project, but Japanese people, they don't understand English, they don't understand Hindi or any other language, so their preferred language is Japanese, right? And you don't know Japanese, so you are a data scientist, you are working on their project, you don't know Japanese. So how you are going to communicate with them? How you are going to communicate with your client who is from Japan and they don't have any, you cannot talk with them in English because they don't know English. So how you're going to work with them? So what you will need? You will need a translator who knows Hindi as well as who knows Japanese as well, or English or Japanese, right? So what you will do, you're going to convey your message to translator, then translator is going to translate whatever you have conveyed to in Japanese, right? So this will be so you require a translator to communicate with them, right? Similarly, in high level language, we use some keywords, some English keywords and symbols to convey our messages, convey our instruction to the computer. Okay, now based on this, the languages, okay, be it C, C++, you have some keywords and some symbols that you will be using to convey your messages to your instruction to your computer. Now whatever code you are writing, you're going to use some English keywords like print something. So this is nothing but this is an English keyword, right? And then you are using this symbol bracket, and in bracket you will pass something, right? So this code is high level. Once you have written your code, it needs to be converted in machine understandable form. So machine can only understand ones and zeros. Now it is the work of this compiler and interpreter. Okay, it is the work of compilers and interpreter to convert your code from high level language to low level language. Okay, so from English, your keywords and symbols, it gets converted into zeros and ones. So you don't need to translate this yourself. You don't need to learn the language, which is binary, zeros and ones. What will be the binary equivalent of 10? What will be the binary equivalent of 100 and so on? It is the work of compiler and interpreter. Okay, so these works as a translators. Compilers and interpreter, they actually work as a translator. Okay. Now, based on different programming languages, okay, compiler and interpreter, these are two different things. Okay, Python, it uses interpreter to convert its high level code into low level language, okay, into zeros and ones, whereas C++ uses compiler. Okay, so there is a bit of difference between this compiler and interpreter. This low level languages, they don't need, there was no need of compiler or interpreter. So this used to be really fast because you don't have to convert anything into binary, because directly it was converted into binary and stored. Now, high level programming languages is designed for developing user friendly software programs. This programming language requires a compiler or interpreter. So compiler or interpreter, not both of them. So C, C++, they have compilers. Java also have compiler. Python, Perl, Ruby, they all have their interpreters, okay, to do this conversion. Okay, so now we are going to talk about high level languages. So high level languages are nothing but the codes that you write, like Python, C, C++, and all. So a high level language is further divided into three parts. What are those three parts? Procedural oriented programming language, object oriented programming language, and the natural language. Okay, so natural language is nothing but the language that we humans speak. Okay, so natural language is nothing but the language that we as human speak or use to communicate with. Now, procedural oriented programming language. Okay, so procedural oriented programming languages, it divides our program into small procedures called routines or function. Okay, so here what we do is, in procedural oriented programming language, you create different modules when you are writing your program. So we create this different modules and we combine all of them into a main program. So we write our code in smaller pieces, not all at once. For example, let's say you are building a calculator. Okay, you want to make a calculator. So to make this calculator, I will need some functionalities from this calculator. This calculator should be able to do the addition, right? This calculator should be able to do the subtraction, right? This calculator should be able to do the multiplication, division, find the square root, and so on, right? Multiplication, division, find the square root, and so on. There's going to be a lot of application of it. So here, instead of writing all this at once, what you can do is you can divide your programs into sub modules. So you can divide your programs into different modules, different procedures. One module, one function will perform the addition. Another function might perform the subtraction. Okay. Then another function might perform the multiplication. And another function can perform the division. So what we do in procedural oriented programming languages, we divide our programs into different sub parts, different sub modules. That's our procedural oriented programming languages. So C, Fortran, Basic, Pascal, and there are other programming languages which support this procedural oriented programming. Okay. Then we have something known as object-oriented programming language. So in object-oriented programming language, our programs are divided into small parts called objects. Now, what are these objects? We'll see. In the program to make the in the program to make this program reusable, so this kind of programming, it makes our code reusable. So you don't have to repeat yourself writing same logic again and again. It makes it efficient and easy to use as well. So Python follows this object-oriented programming languages. C++ you can use object-oriented programming design. Okay, so these all are your object-oriented programming languages. Now let's understand what do we mean by object-oriented programming language. Let's say you want to store some data, some information about your employee. Okay, so you want to store the information about your employees. So here you will require their name, right? We'll require their names. We will require their age, right? Their how much salary we are offering to them. So we'll require their salary information as well. Correct. Then after salary, let's say you also require their experience. So you'll require their experience as well. Okay. Then let's say we just want to store this information. So their email ID, their phone number, and a lot of things you can store. And also you want to store what is their role, what is their day-to-day job. So in that case, you will define some functions for them, right? What is their job role? So job role. Okay. At which location they have to report. So where they have to report. Right? And all this thing. So you are going to have not just one or two employees. You're going to have, let's say, hundreds of employees. Right? So in this case, what you can do is you can define one class. A class is nothing kind of blueprint to store this information of your employees. Okay, so what you can do, you can define a structure, a blueprint to store this information of the employee. So here I want to store the name, right? I want to store the age, I want to store the salary and the experience. So this is my blueprint. What is this? This is my blueprint. I don't have any data as of now, but I have my blueprint ready. So if one employee joins, I can enter all his details. For example, name, age, salary, and experience, and all this stuff. So we call this as the attribute of the employee. So each employee is going to have this attribute. Each employee is going to have name, age, salary, and experience. So here I'll enter the name, I will enter the age, salary, experience of the first employee. Right? Then for the second employee, when the second employees join, I will enter the details of the second employee. So I don't have to create this structure again and again. Right? I have a kind of blueprint already designed for me. Whenever someone is going to join, I will require this attribute of that particular employee. I can feed in the data, and also I can define some operations, some functions that those employees will do. Okay, what is their job role, which project they are working on, what is their reporting place or manager, and so on. So this kind of program designing is nothing but this is your object-oriented programming language. Okay, so you define classes and you have objects. So objects are nothing but your real world entities, which is the employees. Employee 1, that will be your object 1. Employee 2, that will be your object 2. Right? So that is your object-oriented programming language. Okay, so natural language processing. Natural language is just a part of human languages, as I told you, like English, Russian, German, Japanese, Hindi, uh, Tamil, Kannada, right, Marathi, and so on. It is used by machine to understand, manipulate, and interpret human languages. So nowadays, you will see that programs are getting smarter, right? You'll see virtual assistants, you'll see chatbots. They are able to communicate with us in our own languages, right? How they are able to communicate? Because we are feeding this kind of intelligence in them. How we are feeding this intelligence? Through data. We are providing a lot of data to them from which they can learn, right? So again, it is just limited. It is not so that they can develop all this intelligence uh, by themselves. So it requires you to provide the intelligence to these machines as well. So it require human interventions as well. All right, so that's all for today. Let's just quickly recap, okay, what we have done. So today is the very first session. That's why we are not getting into any kind of writing programs. That we will do from the next session. This was just a session to get you familiar with programming, what are programs, okay, how actually computer understand whatever code you're writing, what is the process that is happening in the backend. So your code getting converted to binary form and then getting executed. And what is Python? What are the functionalities of Python? What you can do with Python? That's all that we have covered today. So for web development, you can use these libraries. We have talked about Django, Flask, Pyramid. For game development, you can use PySoy and Pygame. For machine learning, we'll be using Pandas, Scikit-learn, NumPy, and Matplotlib and Seaborn. So data science and data visualization. For making desktop GUIs, you can use Tinctor, WX widgets, Kiwi, PyQt, and others applications as well. And for web scraping application, we have Beautiful Soup. Okay, so yeah, that's all that we had for today. All right then, guys. So thank you, folks. That's all for today. We'll meet again in next session. All right. So thank you and have a good day.